The Skinny Call Control Protocol is a Cisco proprietary signaling protocol. That means it sort of fits the same place in voice over IP that SIP and H.323 do. Now, Skinny is also very proprietary, so you're not going to see Skinny implemented on anything but a Cisco. And so immediately you sort of say, well, why would I engage in a proprietary protocol? It's dangerous to do. And that's true. But I have for you here a quote from a voice over IP conference that we did here at RIT. Millions of installed Cisco phones would argue for the continued use of Skinny as a protocol. So if you got lots and lots of Skinny gear, and you have lots and lots of Skinny phones, and you're going to use Cisco phones in the future, then there's nothing really wrong with going forward as Skinny. It's highly effective and really, really easy to read and to troubleshoot. Now, it's called Skinny, and if you compared it to H.323, if you've ever looked or tried to debug an H.323 data stream, it's extraordinarily painful to go through. And so from that perspective, Skinny is certainly a lot easier to read than H.323. But SIP is also pretty easy to read too and understand what's going on. So if you're comparing the two, if you've got Cisco stuff, go Skinny. If you don't have Cisco stuff, go SIP. When you've got Skinny implemented, the signaling protocol is going to connect on port 2000. So that's the one that's reserved for Skinny. When phones have registered, they have what we call a pervasive connection with a call manager. So they've got this keep alive with the call manager, and actually it can be sort of a pain to move Cisco phones from one number to another because of that connection. Now, like all voice over IP implementations, you use the signaling protocol, in this case SCCP or Skinny, and then you drop into RTP for voice transport. One of the big differences in a Cisco implementation is that there's no RTCP. So from that perspective, this is not a standard sort of VoIP implementation. So if you're looking for RTCP packets, you're not going to see them at all. Cisco has some other things that it uses instead, and we'll take a peek at those later on. Another difference is that we don't see RTP used for anything but voice transport. So as I mentioned, Skinny messages are really, really simple. The message header for all of them is exactly the same. You have a header data length, version, and then the message ID, as you can see here in this register message example. Depending on the message type, then the header expands, or the packet expands to include different kinds of information depending on the message type or the message ID. But all of them share this sort of common header format. Very easy to read. And you can see that with the Wireshark dissector, the name of the message sort of tells you the whole thing. Now, what I wanted to be clear about is that even though we're switching between some of the other topologies, we've talked about Avaya topologies, Polycom topologies, all voice over IP implementations share a bunch of common items or common components in the topology, and the Cisco is no different. So you've got your interconnections there, this via the switch, and I've got a couple monitors in this particular image. You got your phones, and then you got a call manager connected in there somewhere. The difference here is that in our labs, our students are dealing with Call Manager Express. So this is the sort of entry-level call manager for Cisco. And when you do this deployment, it's very simple to put the TFTP server and the DHCP server right on the router. In fact, things get a little confusing if you put the TFTP server anywhere else. So everything's right there on the router, so you don't have additional servers laying around, all in one box. Of course, the difficulty is if anything goes wrong with that one box, you're toast, right? We have the same operational stages. So when you plug phones in, the first thing that they do is they try and do DHCP. And from DHCP, they learn where the TFTP server is. And this is maybe one of those places that Cisco departs a little bit. Cisco phones discover the call manager through a different mechanism. Normally, VoIP phones will pull down from the TFTP server the location of the call server and the how we might configure the interfaces, things like that. Or they might pull this from the DHCP server, call manager, things like that. On the Cisco, we do this with CNF files that you TFTP directly from the router. And that's one of the reasons why it's nice to put the TFTP server, or is important to put the TFTP server in the same place as your Call Manager Express box, because of those CNF files. And this is just a graphic that shows you the tremendous number of different Skinny messages. I mean, there are just piles and piles and piles of them. And again, you can see that from their descriptions there, the info, that the Cisco message or the skinny message tells you exactly what this message is trying to do. So we've got button pushes and line status and time and date, registration, all that kind of stuff is right in the title. And so there's lots and lots of skinny messages. And you can see that in this particular case, the phones were going right out to the call manager, and all of these messages were coming in one direction. Well, after we DHCP and TFTP and register with the call server, we're going to start doing something. And so we're going to go off hook here. And this is one of the places where Cisco implementations differ from a lot of them. We tell the phones to play a particular tone. This is different than a lot of implementations, because what we see on Avaya's, for example, is that we're sending RTP packets that include dial tone. And we don't have that on a Cisco implementation. On the bottom part of the screen here, we see our address signaling. Again, it's very clear what's going on here. We've got a keypad button message, and then the number that was dialed when you hit that particular key. So very straightforward, very easy to troubleshoot if you can see inside the packet. And here is our teardown. We've got a couple of things that are going on. We've got a stop media transmission, which tells us that we are no longer going to be sending RTP packets. And then we close the channel, or what we might call the session between the two endpoints. So a very graceful sort of teardown, but again, very clear on what's going on here. You might guess from these messages that at the beginning of this, we had a start media transmission message. And the last thing that I wanted to point out here is that as we, throughout the course of the conversation, instead of getting RTCP packets, and if you recall that RTCP is there for quality of service measurements, packets, latency, bytes, things like that, we've got connection statistics requests and response on the Cisco implementation with SCCP. So these are the packets that say, hey, tell me about the packets and the octets and the timing that you've got on these particular packets instead of RTCP. And this is, I think I pointed out at the beginning of this video, this is one of the big places that Cisco differs from what we might call a standard voice over IP implementation.